Do you think we're alone out there?
You know, that question sounds simple. It sounds like something you'd ask looking up at the sky on a camping trip. But I want to tell you something. That question, the way you just asked it, contains an assumption so enormous that when I tell you what it is, you are going to feel the ground shift under you a little. Are you ready for that?
I think so. Maybe?
The assumption is the word out there. You said out there. Like the universe is a room, and we are standing in it, and we want to know if someone else is also standing in it, somewhere across the floor. But here is the thing. The universe is not a room. It is not even close to a room. It is something so staggeringly large that human language does not have the right words for it. And human intuition, beautiful, reliable, useful human intuition, is absolutely, completely, magnificently wrong about it. And that wrongness is not your fault. It is nobody's fault. It is just that our brains evolved to handle distances like how far is the river and how far is the next village. Nobody needed to survive by understanding how far it is to the edge of the observable universe. So we didn't develop that muscle. And here we are, trying to talk about something our brains were never built to hold.
Okay, so how wrong are we talking? Like, a little wrong or embarrassingly wrong?
Embarrassingly. Cosmically embarrassingly. Let me give you a number, and I want you to really sit with it. The nearest star to our sun, the nearest one, the next door neighbor, is about 4 light years away. Now, a light year is the distance light travels in 1 year. Light moves at a speed that would take it around the entire Earth 7 times in 1 second. 7 times in 1 second. And even at that speed, it takes 4 years to reach our nearest neighbor. Now you send a spacecraft. The fastest spacecraft humanity has ever launched was New Horizons, which went to Pluto. Lovely little mission. At that speed, at the fastest thing we have ever built, it would take roughly 73,000 years to reach that nearest star. 73,000 years. The entirety of recorded human civilization is about 5,000 years old.
Wait, so we'd need like 15 full runs of all of human history just to get to the next star over?
Say that again because I want the people listening to feel that, yes. 15 full replays of everything humans have ever done. Written, built, loved, fought, discovered, and you are still not there. And that is the nearest one. There are somewhere between 200 and 400 billion stars in our galaxy alone. And there are more galaxies in the observable universe than there are grains of sand on every beach on Earth. Now go back and ask me if we are alone out there. Feel how different that question is?
It feels almost like a different question entirely.
It is. And here is where the Fermi Paradox walks into the room. Enrico Fermi, brilliant man, one of the most precise thinkers I ever encountered in this work, was having lunch with some colleagues at Los Alamos. Just lunch. And someone was talking about the possibility of extraterrestrial life, and Fermi listened, and he did that thing he did where you could see him calculating behind his eyes, and then he put down his fork and said, very quietly, "But where is everybody?" And that was it. That was the whole thing. Where is everybody? Because if the universe is this old and this large, and stars and planets have been forming for billions of years before our sun even existed, where are all the civilizations? Why haven't we heard from them? Why haven't we found a single trace?
And that's the paradox? That it should be crowded, but it's silent?
That's exactly it. The math suggests the universe should be teeming, the silence suggests it isn't, and the gap between those two things is the most haunting question in all of science. Now, there are many explanations people reach for. Maybe civilizations destroy themselves. Maybe they go quiet on purpose. Maybe physics puts a hard ceiling on how far you can travel. And I find all of those interesting. But I want to tell you about an explanation that doesn't get discussed enough. One that I think is the most honest one. And I'll get to it, but first I need to tell you something about time that is going to change the way you hear everything else I say today.
You're doing this thing where I feel like I'm not allowed to look away.
Good. Don't. Here is a question for you. If I asked you what time it is right now, what does that mean?
It means what the clock says?
Yes, but whose clock? That is Einstein's great gift to us. Time is not a river flowing at the same rate everywhere. Time is not universal. Time runs differently depending on how fast you are moving and how close you are to a massive object. This is not philosophy. This is not metaphor. This is physical reality, measured, tested, confirmed, used every single day in the GPS satellites above your head, which have to correct for exactly this effect, or they would give you wrong directions within minutes. The clocks on those satellites run at a different rate than clocks on the ground. We account for it. It is real.
I knew GPS involved satellites and signals, but I had no idea time was in there.
Time is in everything. Now here is where this connects to Fermi. Imagine a civilization, not on Earth, that developed maybe 2 billion years before us. 2 billion years is hard to grasp, so let me put it this way. The first life on Earth appeared about 3.5 billion years ago. We have been walking upright for maybe 2 or 3 million years. Our civilization is a blink, so 2 billion years. A civilization with 2 billion years of science and engineering and curiosity. What have they built? Where have they gone? What would they have done with physics we haven't discovered yet? The silence should not be silence. It should be noise. It should be overwhelming evidence of their presence. And yet nothing. The sky is quiet.
So either they're not there, or they're hiding, or,
and this is the one that sits with me, we are simply early. We may be among the first. Not in the sense that we are special or chosen or remarkable, but in the purely cold statistical sense that the universe had to produce its first generation of civilizations eventually, and perhaps we are in that generation. The universe is 13.8 billion years old. It took roughly 9 billion years for our sun to form. We are early in the story. The plot has barely started. Most of the stars that will ever exist have not yet been born.
wait, most stars haven't been born yet?
The universe is still in its star-forming years. We are in a period of stellar adolescence, cosmically speaking. 92% of the stars that will ever exist in the lifetime of the universe are yet to come. Planets around those stars, planets that might host life, have not formed yet. The vast majority of what this universe will produce in the way of complexity and life and thought and whatever else is ahead of us, not behind us. We may have arrived at the party so early that the building wasn't even finished yet. There might be nobody here because nobody else is here yet.
That's okay. That is deeply strange. And somehow lonelier than the other explanations. Like somehow, you're too early feels more isolating than everyone's hiding.
You just said something I want to hold for a moment, because you are right that it has a particular quality of loneliness to it. If they are hiding, there is company somewhere. If they destroyed themselves, at least there was traffic at some point. But if we are genuinely among the first ones to look up, to wonder, to build instruments and point them at the sky, then the universe has been here for nearly 14 billion years in a kind of silence, and we are the first voice. Can you feel the weight of that?
I can. I really can. I feel like I need a minute and we don't have a minute.
Let's take one anyway, because this is not a small thing. I have sat with this idea for years, and it never gets lighter. It only gets more beautiful in a strange way. If we are early, if the universe is still young, and its greatest complexity is still ahead, then what we do now matters in a way that almost nothing in our daily lives prepares us for. We are not a footnote at the end of a long story. We might be the first chapter.
But then here's what I want to ask: if we're early and those future civilizations come later, are they going to find us? Is there going to be evidence that we were here?
Now you are asking a physicist's question in the best possible way. Here is the thing, and this is the part I want you to stay with, because it is genuinely strange. The evidence that we exist is already traveling. Every radio signal we have ever broadcast, every radar pulse, every television transmission, all of it is moving outward at the speed of light in every direction. Our first deliberate radio signal is about 120 light years away from Earth right now. There is a sphere, a bubble of radio noise, expanding around our solar system. And in that bubble is the complete record of the 20th century played outward into the cosmos.
So we're already shouting.
We have been shouting for a century. The question is whether anyone is close enough and old enough and listening on the right frequency. And here's where I want to run a thought experiment with you. Are you ready?
Absolutely.
Picture the Milky Way from above, a great flat disk spiraling 100,000 light years across. Drop a single grain of sand somewhere in that disk. That grain is our solar system. Now imagine that across that entire disk, in the last 100 years, civilizations have been turning on their radios. Some of them did it 1,000,000 years ago, some of them did it yesterday. But each one, when it turns on its radio, starts making a small bubble of signal that grows at the speed of light. How crowded does that disk look to you?
I mean, it depends how many civilizations there are, right?
Yes. And this is where the Drake equation lives the attempt to estimate that number. Frank Drake in 1961 sat down with a group of scientists and wrote on a blackboard the factors you would need to multiply together to estimate how many civilizations might be communicating at any moment. It's a beautiful piece of work, not because it gives you an answer, we don't know most of the variables, but because it forces you to ask the right questions in the right order. And the extraordinary thing is, in recent years, some of those variables we could barely guess at have gotten sharper. We now know there are planets around nearly every star. We know liquid water exists in more places than we imagined. The conditions for life are apparently not rare, and yet the sky remains quiet. So either the step from simple chemistry to life is nearly impossible, or the step from life to intelligence is nearly impossible, or intelligence always destroys itself, or we are early.
Which one do you think it is?
I think it is almost certainly some combination. I think the universe is vast enough and strange enough that the answer is not one clean thing. But if you pushed me, if you made me sit here and give you one honest answer about which explanation makes the most physical and historical sense given what we actually know, I would say we are early. I think we are witnessing the universe wake up. And I think that is the most astonishing position any species has ever found itself in.
What does it mean for us, if that's true? Like practically, what do we do with that?
This is where I want to tell you something about how scientists think, or should think, about the future. We are not good, as a species, at caring about things very far away in time. We struggle to care deeply about what happens 100 years from now. But if we are early, if the civilizations that come after us in this galaxy are going to be shaped partly by whether we survived, by what we left behind, by whether we managed to become a multi-planet species before something ended us, then the decisions being made right now, in this century, have a weight that is almost unbearable to look at directly. We are not just living our lives. We might be setting a precedent for life in this galaxy for the next billion years.
That's terrifying and kind of beautiful at the same time.
That is exactly the right reaction. That is the only honest reaction. Terror and beauty together, that is usually where the most important things live. I learned that doing physics. Every time I encountered something that made me feel both frightened and exhilarated at the same moment, I knew I was close to something real.
Is that what it feels like to be a scientist? That combination?
At the best moments, yes. When you are working on something at the edge of what is known, there is this particular feeling. I don't have a great word for it. It is like standing at the top of a very tall cliff in the dark, and you can hear the ocean somewhere below, but you cannot see it, and you don't know how far down it is. And instead of stepping back from the cliff, you lean forward. Not because you are reckless, but because you want to hear it better.
I think that might be the most precise description of curiosity I have ever heard.
Curiosity is just courage wearing comfortable clothes.
Okay, I have to ask this. If you could send one message, knowing it might reach a civilization that doesn't exist yet, some species that will evolve somewhere in this galaxy 1 billion years from now, what would you say?
You know, my first instinct is to say something grand, to reach for the poetry. But I think the honest answer is simpler. I think I would say we were here, and we were confused, and we were trying, and we thought the questions were worth asking even when we couldn't answer them. Because that is actually the most dignified thing I can say about us. We asked, we kept asking, even when it cost us. Even when the universe handed us silence. Even when the distances were ridiculous, and the timescales were crushing, and the odds seemed laughable. We kept pointing our instruments at the sky. That seems worth reporting.
I think if I received that message, I would feel I don't know less alone.
Yes. And maybe that is the answer to Fermi's question that no one talks about enough. Maybe the universe is not silent because it is empty. Maybe it is silent because everyone who has ever been in it was asking the same question at the same moment and none of the signals have had time to arrive yet. Maybe the silence is not emptiness. Maybe it is everyone listening at the same time.
That is, I want to sit in that for a second.
Take all the time you need.
Okay, last question. And I feel like I already know it's going to follow me home. If we are the first, if this is really the beginning, does that mean we're the most important thing that's ever happened in the universe so far?
I want to flip that question over, because there is something hiding underneath it. You asked if we are the most important thing. But important to whom? The universe does not have preferences. Stars do not care. Gravity does not cheer. The question of importance only exists because we exist to ask it. And I find that not frightening, not humbling in a diminishing way, but genuinely staggering. The universe produced something that can look back at it and ask what it means. That has never happened before, as far as we know. That is not nothing. That is an extraordinary accident that became the only thing in the universe capable of recognizing accidents as extraordinary. So let me ask you something instead, and I want a real answer, not a polished one. When you look up at the sky tonight, really look. Knowing what we've talked about, knowing you might be among the first minds this universe has ever produced that was capable of wondering about its own loneliness, what do you feel?
Honestly, I feel like the sky got bigger, and I feel like I owe it something, like I should pay more attention. Like maybe paying attention is the only thing any of us can really offer back.
That is the right answer. That is the only answer. And it is more than enough.